Okay, pointers and arrays. Pointers and arrays. So we discussed pointers separately, arrays separately. Separate modules are there. Pointers and arrays. Discuss in both. But now let us try to combine them. Or in specific how to implement arrays using pointers. C language internally actually implements arrays using pointers. Okay, so how we implement arrays using pointers? We implement arrays using pointers. See, pointers and arrays are closely related. A pointer can be used to implement an array. When an array is declared, memory is allocated during compilation time. So that is one important point. When an array is declared, memory is allocated during compilation time. When an array is declared, when the memory is allocated, it is allocated during the compilation time. Memory is allocated during the compilation time. Okay. Using a pointer, same array can be implemented by allocating the memory during execution time. The difference you can see. So if we just use directly arrays, memory is allocated during compilation time. If we use pointers to implement an array, memory for the array part, that means the pointer will be pointing to something, that is array. The memory for the pointer, not pointer, but the memory for the locations to which the pointer is pointing, that is allocated during execution time. Here there is a little confusion. See, memory for a pointer variable is allocated during compilation time. Memory to which the pointer is pointing, is allocated during runtime or execution time. That point you remember. Usually this point the books doesn't mention, say the case of pointers, memory is allocated during runtime, but it's not correct. So we have a pointer, we have already used pointers. We have not used anything like dynamic memory allocation. So that means for the pointer variables, the memory is allocated during compilation time only. For the data to which the pointer is pointing, that memory can be allocated during the execution time, depending on the requirement. So what is the use of pointer means? It allows us to use the memory efficiently. We may save the memory also. We have seen that in the case of array, we have to specify the max size, maximum size. So whether you use all the memory locations or not doesn't matter. Whether you use all the locations or not doesn't matter. But you will be allocating the memory equal to the max size. So in case of pointers, if you use pointers to implement arrays, then depending on the requirement, depending on the number of elements that are possible, you allocate that memory only. You allocate that amount of memory only, not max size. So it allows us to efficiently use the memory. It may save the memory also if we are not storing the max size elements. But the disadvantage is it increases the execution time. Why it increases the execution time? Why? Simple reason. Because if you do say one task during execution time, it takes some time. If you take two tasks, it takes more time. Now the programming statements are to be executed. So apart from it, apart from it, you are allocating the memory also. Allocating the memory also to consume some time. That means it takes more time for the program to execute. If you do something during the runtime, it takes more time for the program to execute. That is a simple reason. Making pointer point to an array. Making pointer point to an array. A pointer can be made to point to a scalar variable and also an array. Okay. Before we discuss how to directly use pointers without using arrays, so first we will discuss pointer, using pointer and also using array, and how to make the pointer point to an array. That we will discuss. So without declaring array also we can achieve the same result. That we will see in the next slides. Okay, making a pointer point to an array. Okay, a pointer can be made to point to scalar variable, or that means a single variable, or to an array. So what we have done, if PV is the pointer, PV equal to UnDA, we have written PV equal to UnDA. So we have seen that those examples, PV equal to UnDA. If PV is the pointer variable, PV equal to UnDA, that means, so the address of A is stored in pointer variable PV. Address of A is stored in pointer variable PV. Now we have to store the address of the array. So how it can be done? It can be done like this. Now note that there is no ampersand. So again, I don't know why the ampersand goes off, but it is PV equal to UnDA. There is some issue with this tool. Okay, PV equal to UnDA, ampersand you have to specify. But whenever you are using an array, you are not specifying any ampersand. What is the reason? The reason is, we already discussed in the strings part. What is the reason? Because array name itself represents the starting address. So here array name is nothing but array, so it itself represents the starting address. So, or otherwise want to be explicit, you can do it like this, and of array of 0, that means starting address, this you can do. So this makes a pointer point to an array. Note that the array name itself represents the starting address of the array. A pointer variable can be made to point to other elements of the array also by just incrementing and decrementing pointer. So you have array of elements. Okay, you are making the array point to the starting element, but you can go to the next element, second element, third element, like that, by just using pointers. Without using this array indexes, array of I, array of 2, like that, without using that, you can just use pointer and you can increment and decrement. So if you remember carefully, so we discussed pointers. As part of those pointers, we discussed pointer operations that can be performed on pointers. You can refer to that topic if you want. So incrementation and decrementation can be done. Okay. So by incrementing, you can go to the next element. By decrementing, you can go to the previous element. So you can achieve traversing of this array, moving from left to right and right to left in an array, by using just pointers, by using incrementing and decrementing. So this please remember correctly. It is always confusing, but this is the plain thing. If you understand this thing, it is easy. Okay. If P is pointing to an array, then if P is made to point to an array, then P represents the starting address. P represents the first element of the array. So if you want the second element, just increment it by 1, independent of the data type to which it is pointing. Remember, the array can be homogeneous collection of elements, but those elements can be integers, characters, floats, double, and even structures. So whatever it be, we just increment by 1. If you want to go to the next element, increment by 1. If you want to go to the next element, increment by 2. So you need not increment it by, say, in case of integer it is say 2 bytes or 4 bytes, so we have to increment by 4. In case of double, maybe it is 8 bytes, so increment by 8. Nothing like that. System takes care of it. You just increment by 1 to go to the next element. Maybe decrement by 1 to go to the previous element. So p plus 1 represents the second element, p plus 2 is pointing to the third, p plus 3 is pointing to the fourth element. In general, p plus I points to the I plus 1th element. Remember, indexing has started at 0, that's why p plus I, instead of pointing to the ith element, p plus 1 actually points to the I plus 1th element. P actually points to the first element, not 0th element. So the first element is one that is array of 0. Okay. So P plus I points to the I plus 1th element of the array. So that is regarding the addressing. Now if you want to retrieve the value, then star P is the value of the first element. P contains actually the address. P plus 1, P plus 2, they are incrementing the address. Star P is the value of the first element. Star of P plus 1 is the value of the second element. Similarly, star of P plus I within the parentheses, you have to use the parentheses without fail. Because again, this precedence of operators, etc. comes into picture. Star of P plus I is the value of the I plus 1th element of the array. Is the value of the I plus 1th element of the array. So if you want to go to the I plus 1th element, if P is pointing to the first element, if you want to go to the I plus 1 element, then write P plus I. If you want to retrieve the value, if you want to retrieve the I plus 1th element value, enclose that P plus I in parentheses and put star. So that is a simple rule. You just remember these two. Okay. Just remember these two. Take a snapshot. So while listening to the videos, take some notes. The reason is not that you become a good student, good listener, but your hand has connection with the brain. So whenever you write something, your brain automatically gets activated. Okay, that is the logic. So pointer pointing to an array. Here you can see an array. So pointer is pointing to an array. The pointer can be made to the starting element of the array, and then the next element, etc. can be obtained by just incrementing it. Dynamic memory allocation C. Okay. Now this is one important topic. Dynamic memory allocation in C. What is this dynamic memory allocation? Dynamic means if anything happens during runtime or execution time, it is called as dynamic. Static means compilation time. Dynamic means runtime. Static means compilation. Dynamic means runtime or execution time. Dynamic memory allocation. We discussed that For the array, memory is allocated during the compilation time, and also for simple variables like say int ABC, for ABC also memory is allocated during the compilation time. Now we also discussed that using pointers we can allocate the memory dynamically and we can use the memory efficiently. Now how this memory is actually internally organized? How this memory is actually internally organized? What is the support for dynamic memory allocation? We will see in the next slides. But before that, how the memory is organized. How the memory is organized. Okay, how the memory is organized. So the memory is organized into 4 parts actually. The test part which contains the code of the program. Test part which contains the code of the program. Okay, test part which contains the code of the program. The data part, this data part contains say the global variables, global or external variables. Okay, so in simple terms, variables, the variables whose values are valid throughout the program, not just restricted to functions, etc. Throughout the program, those variables are valid, or values of variables are valid. So this is for global variables. Now this heap part is for dynamic memory allocation. Dynamic memory. So heap part is for dynamic memory allocation. So whenever you are trying to allocate the memory dynamically, it will be allocated in the heap part. And stack part contains these return addresses, values of return addresses in case of functions, return address, and also these parameters. Okay, parameters. So return address and parameters, they are stored in the stack part. And you can see the arrows. So this arrow actually starts here. The meaning of these arrows is stack part should be like this. Okay, I cannot do it during the slideshow, but the point is stack part goes in this grows in this direction, and heap part grows in this direction. So the opposite way. Stack part grows in this direction, and heap part grows in this direction. So remember, depending on the number of functions that you are using, the stack part may change. Okay. Remember, stack is last in first out, so you will be automatically adding, etc. Depending on the number of functions, return addresses, the stack grows in this direction, heap grows in this direction. But important point here is heap part is used for dynamic memory allocation, and in C language we can allocate the memory dynamically. So test part contains code, data part contains global variables and also other type of variables. These are all storage classes. Extern is there, extern storage class, that is for global variables. Static variables are there, register variables are there, register variables which are stored in registers if possible, and then by default auto variables, automatic or auto variables. Static variables are there, static variables, if you use the storage class static, then the values of the variables are retained during the function, during several function invocations. Maybe we will discuss programming example of it in a separate session. Okay, that also we have to do, if not done. If possible, let me try to edit the order of the videos, and you study that one first and then this one. Okay, data part contains the global variables, and stack and heap areas can grow and shrink in size, and space should be there to expand. So usually they are arranged one above the other and each going in the opposite direction. Stack contains the return address and also local variables. Heap is for dynamic memory allocation. Okay, the other important point which is generally not mentioned in the books, I think I mentioned it previously also. So when the memory is allocated, so the pointer can point to a single data item or to a collection of data items like array and structure. The memory is dynamically allocated to the data to which the pointer points to, and not to the pointer itself. To the pointer, the memory is allocated during compilation time. So that means for the pointer variable, if you declare just say integer star a, for a, the memory is allocated during the compilation time. Now, if you make the a point to some memory locations, some data items, say array, without declaring the array, then you can allocate that memory during the runtime. So this memory, the data to which the pointer points, that memory is allocated during the runtime or dynamically. For the pointer itself, the memory is allocated during the compilation time. So this point you please remember. If possible, you can note down this last statement, because usually in books it is not mentioned. Library functions related to dynamic memory allocation. So we discussed that memory can be allocated dynamically. How? What are the library functions? There are four library functions which are used for dynamic memory allocation. So the first one is called as malloc. Here you can see this is the syntax. Malloc is for dynamically allocating a single block of memory with a specified size. That means you have to specify the size. It cannot be used to increase or decrease the size of the memory. If you want to increase or decrease, there are other functions, particularly only increasing, actually decreasing is not permitted. If you want to increase, there is another function which we will discuss. But if you want some fixed size memory to be allocated, if you know the number of elements, say, then you can allocate the memory using malloc function dynamically. So the syntax is pointer equal to data type star malloc size of data. So malloc is the name of the built-in function. You have to use as it is. Okay. Next, size of the data, you have to specify how many data items will be there. So if you want to store 10 data items, you have to specify it as 10. If you want, you can declare a hash define max size also, and then max size can be mentioned here. So within the parentheses, you have the data type. That means the data type of the elements to which the pointer is pointing. So it can be int, float, double, or it can be structure also. So we'll see how to do it with the structure. Maybe at the end we'll see. So pointer equal to data type star malloc of size of data. So the example is like this. Pointer equal to integer star malloc size of data star size of integer. Okay. So you have to specify. Size of data. So if you have 10 data items, you should not specify just 10. 10 star size of int. You don't bother about what is the size of int. You just use size of function. So if integer occupies 4 bytes, then 10 into 4, that is 40 bytes will be reserved. 40 bytes will be reserved or allocated, not reserved actually. It's better we don't use that term. Is allocated. So malloc function, this will be used, commonly used one. Next is calloc. Calloc stands for contiguous allocation. Calloc stands for contiguous allocation. It is similar to the malloc except the data block that is allocated is initialized to 0. So it is initialized to 0. The starting address of the memory allocated is assigned to a pointer if memory allocation is successful, otherwise it returns null. So if memory allocation, both in the case of malloc and calloc, if it is successful, it returns the starting address. Okay. Otherwise it returns null. The format or example is like this. Generally we don't use calloc, but anyhow, if necessary, can do it. Next, another important function is free pointer. That means, okay, you have allocated the memory. You are saying that memory is allocated dynamically. Fine. If it is just allocation, then probably we will be going on allocating the memory. So if you want to really use the memory efficiently, then there should be a way of freeing the memory also, deallocating the memory. You have used it, so you no longer need it. Then what you have to do? You have to free it. That can be done using free function, free pointer. That means, so pointer is pointing to a collection of data items, some data items. So if those data items are no longer required, then use this free pointer. Free followed by within it the pointer. That means the freed memory can be reused. So if you use both allocation and deallocation, if you do both allocation and deallocation, then it is using the memory efficiently. Otherwise, if you just allocate the memory, it is half the work done. Next, last function is realloc. So realloc stands for reallocation. As the name indicates, it is used to dynamically change the amount of memory that is allocated. Dynamically change the amount. Okay, you can allocate using malloc, calloc, you can allocate the memory. But what happens? During runtime, you want to change it. Then you can use realloc. Okay. Realloc to increase the amount of memory that is required. So as usual, it returns a pointer, starting address, and then otherwise it returns null. But example you can see here, you have allocated memory to the pointer, okay, and now you don't have 10 data items, you want 20 data items. In that case, you can just use realloc function, realloc 20 star. That means this 10 will be there. So total it becomes 20. So this memory layout of the C program is taken from Geek for Geeks, not exactly, but the referred site is that one. So the point is there are a number of very, very good websites which you can refer. So to be frank, you don't need even a teacher if you have that will. But unfortunately, because of this intermediate education, you started depending too much on the teacher. And the other one is you started doing the same thing repeatedly. Grinderless rubutunaru. Now the issue here is grinderless rubadam valla emavutundante, so you become mechanical. That means you do things mechanically. You don't use your mind. Stop using your mind. So if you observe, say, carpenter sharpening the wood, then after some time, initially you may take care of it. After some time, what he does, after experience, it does it mechanically. He will be talking to you, you will be looking at the TV, but still you will be doing it. You will be doing it. That means you are not using your brain actually, or mind. Okay, you are using your limbs. Maybe the limbs have the memory. So you do it mechanically. So if you want to really do new things, good things, you have to use memory. So that means we discussed about critical thinking, if you remember. Critical thinking. So you actually require that critical thinking, manual thinking, not automatic thinking. Okay, manual thinking is required. So please try to come out of this intermediate culture, or maybe the school culture also. Remember why this intermediate is called as intermediate? Why it is called so? So what is meaning of inter? What is meaning of inter? Inter stands for in between. So it is actually a bridge. You have school, and you have, say, engineering or degree. So between these, there is actually a bridge. This bridge is nothing but the intermediate. That's why it is called as intermediate actually. So don't try to be in school or intermediate. So now you are a matured person. So self-learning is required. Not that everything you have to learn on your own, but whenever necessary, you should be able to learn. That's where these higher institutions actually differ from a normal university college, affiliated college, private engineering college, etc. Where they differ, they give more importance to the self-study. They work only for 5 days. Okay, it doesn't mean they are free during Saturday or Sunday. That is for self-study. Now you have to grow. Now if you are depending on me, if you are depending on teacher, then while you are doing the job also, you ask, we didn't study it. Nobody taught it to us. No, not everything can be taught. Okay, people will not teach you everything. So people will make you a learner, good learner. That is the purpose of education. So try to learn if anything missing on your own. So be dynamic. Best of luck.